Okay, so now let's implement the first part of the bot. That would be here on the on timer to implement to get the main variables, like the price, the speed, the acceleration, that kind of thing. Okay. Let's get the current price. How does we do it? Okay, let's get the close of the last tick. Okay, the last price we have. We can take that using the market series object, and from that we want the close and the last value, okay, of that close. That will give us the last price of the current symbol, of the current currency pair. Okay, and we need to calculate the speed. Okay, we do it by, let's open here parentheses, the current price, okay, minus plus the previous price. Okay, and we have to divide that by the evaluation time and the user put there, and that will give us the current speed. But we have a couple of problems here. The previous price, we don't have a previous price. We have a previous price here that is not initialized, or maybe we can initialize it with 0, but that's not a real price. So I prefer to take the previous price and here on start, initialize the previous price with the same thing as here, the last close. So when the bot is initialized, it gets the price, and on the first 15 or whatever seconds the evaluation time happens, it gets the current price, and then we have the current price and the previous price for calculating our current speed. We're going to have also another thing there that is not a big thing, but for testing is easier to make it all understandable. If I get the current price and I subtract the previous price, in 10 seconds, that would be maybe 0.5 pips, maybe. So, and if I divide that by the evaluation time, that may be 15 seconds, I will have a very, very, very low number, like 0.000000 whatever. And I don't want to have those numbers because are very, very hard to read. So I prefer to multiply that by the number of digits of the symbol. If it is euro dollar, we have 5 digits. If it's dollar yen, we have 3 digits, and so on. So how do I get those digits? Okay, I have symbol digits, as simple as that. And because here we have all those cool built-in objects that cAlgo is providing. But if I do this multiplication, symbol digits will be 3 or 5. I don't need to multiply by 3 or 5. I need to multiply by 1,000 or 10,000. I 1 followed by 3 zeros or 5 zeros. So I get math. That's an object of C#, not of cAlgo. Power. So I multiply this by 10 to the power of 3 or 5, depending of the symbol of the currency pair. So there I will get in current speed a very legible speed like 5 pips per second or 0.2 pips per second, something more easy when I have to test, and I'm going to show you a little bit later how to test it and how to use the print to see everything that is happening in the bot when backtesting it. Okay, and finally we have to, not finally, there's a lot to do yet, and we calculate this other main variable that is acceleration. That was really hard to see how to implement that, because I initially tried to use your method, that is this method, current speed divided by previous speed, but then I faced some problems, so I went to the physics formula, that is final velocity minus initial velocity divided by final time minus initial time, so I can have, you know, different accelerations, or more intuitive accelerations, but then I have negative speeds and positive speeds, and that would be a problem. So at the end, I ended up using what you told me, that is just current speed divided by previous speed. And of course, if I get a negative number, that means that, you know, the market in that period went to the other side. If that was moving down, then it started to go up, and vice versa. So there's how we calculate the current price, the current speed, the acceleration, and we have all our main variables for doing everything else. What the other thing we're going to do in this part, or in this video, is checking if the acceleration threshold was trespassed. Okay, to see if we go to phase 2. Okay, here we start with our ifs. Pretty basic for any programmer, and normally a bot is very ugly in programming best practices, because we have a lot of ifs. If you see here this martingale, you get here if, else, if. It's pretty ugly. For example, if you make web development, this is very ugly. You need to avoid that. But as here you're trying to implement a logic, something, you know, an intuition, something that is how a person thinks. Well, you need a lot of ifs. There's no way around it. So let me go back to the bot. Okay, and we start with our first if. If the acceleration we just calculate is greater than the phase 2 acceleration threshold, okay, and our phase 2 flag is false, that means that we are not in phase 2. To be in phase 2, we need to be in phase 1, of course. So we need to see if this is false, to be sure that we are in phase 1. If that happens, okay, then we make a base speed. That base speed is what is going to be the speed we're going to make all the calculations in the phase 2. And that's how you put it in the instructions to compare our acceleration to that base speed in the phase 1 and in the phase 2. So that's how I implemented that. So the base speed is just the previous speed. Okay. In the next time this is called, we are going to have different previous speeds, but the base speed is going to remain there. We need that in the future for other calculations. And of course, we need to tell the bot, hey, the phase 2, we are now in the phase 2, so the phase 2 flag goes to true. And that's like the main thing. Okay, we calculate price, speed, acceleration, and we see if we are now on the phase 2. Then if we enter into the phase 2, there's going to be the entry logic and the exit logic, and that's going to be the hardest part of the bot. Okay, so let's build this. We have a problem here that is telling me that it has some invalid arguments. Let me see what can be happening here. Time start, evaluation time. To be honest, I don't know what's happening here, because in my last version it's just this way. So let me see what's happening, and in the next video we're going to implement this phase 2 logic.